So Unit 3, Lesson 4, so number systems. So we're talking about different types of numbers, how they're classified with rational numbers in there. Okay, so recall from Lesson 3, decimal numbers which repeat or terminate can be converted into fractions or called rational numbers. Okay, decimal numbers which are both non-repeating and non-terminating are irrational. Okay, the set of rational numbers and the set of all irrational numbers will be combined to form a set of real numbers. So what that means is these are the following sets of numbers within your number system. Okay, you have natural numbers. This is your positive. Okay, it's your positive whole numbers starting with 1. Okay, 0 is not a natural number. Okay, whole numbers is natural with just a 0. It's the only difference. Okay, then you have your integers, which is positive, negative whole numbers. Okay, and then you have rational numbers, which is any fraction. Okay, and then you have your irrationals are kind of on their own, like separate. Okay, and there's a pretty good little Venn diagram here at the bottom, a lot of people use for math on these. Okay, so again, natural counting numbers 1, 2, 3, 4. Whole numbers, put the 0 in there. Integers, negative and positive whole numbers, including 0. And then rational numbers is your fractions. Okay. So right here is kind of a nice little Venn diagram for it. So you have real numbers. So this section here is your irrationals, which isn't very many. Okay. This is your rationals. This is your integers, and this is your naturals. Okay, so your naturals are whole. Okay, your wholes are integers. Okay, integers are all rational. Okay, so it's just kind of a little Venn diagram of how that works. Okay, any questions on those categories? No? All right. So then moving forward. Okay, so, whoa. Yikes. All over the place. I know, struggling. 3. Yes, passing the time. Here we come. It's coming. This is awkward. Page jumper. All right. Now we're back to where we should be. Okay, so, like we're trying to, example 1, let's not look it too hard this time. Okay, so for each of the following, write all the sets of numbers which fit that given number. Okay, so 9. Is 9 a natural number? Okay. Is 9 a whole number? Is 9 a integer? Is 9 rational? And is 9 irrational? No. So right there, that's all of them, those 4. Okay, and it's real. Okay, so this set is real. Okay, just the non-reals would be the irrational side. So just real is the same as rational, really. It's kind of, you don't really have much to do there. Okay, so the 11 over 7, is that a natural number? Whole number? Integer? So it's just rational and real, because it's a repeating decimal. Okay, or excuse me, these are all real. My fault. We don't even get into non-real. I don't even know why they're putting that on here. That's fine. Okay, square root 5 is a real number. Okay, so they're pretty much going to all be real. So just sorry about the confusion on that. But the root 5, okay, your root 5 is going to be what? Irrational or rational? Irrational. So it's a non-terminating, non-repeating decimal. Okay, and then negative 7. So that's going to be, is that going to be a natural? Nope. Whole? Nope. It starts at what? Integer. So it's an integer, it's rational, and it's real. Real, or Okay. Okay, so then it says the next one, explain why 9 belongs to 5 number sets, but -9 only belongs to 3 of them, because the negative cancels or excludes, however you want to say it, whole and natural numbers. Okay, and then we're just going to talk about square roots and cube roots. Okay, square roots and cube roots. All right, all positive numbers have 2 square roots. Okay, one positive and other negative. The positive square root is called the principal square root and denoted by the symbol, the radical there. Square roots are perfect square are rational numbers. Example, the square roots of 16 are 4 and -4. Okay, now, those are the roots. Okay, when you actually do root 16 in your calculator, you're just going to get a 4, and the answer is 4. But you got to realize that -4 is a possibility. Okay, because what's -4 times -4? It's positive 16. Okay. All right, so the square roots of non-perfect squares are irrational. So the square roots of 17 are root 17 and -root 17. You're not going to get anything nice and smooth like 4 and -4. Okay, and then it has the chart here. And I actually always told you guys last year with your perfect squares, you should know them up to 15. So here's a nice chart up to 15 for you. Okay, 15 squared being 225. That's kind of the ones you should know off the top of your head. Okay. Example number 2, in each of the following, estimate the value mentally. Okay, and then use a calculator to find the decimal approximation. So square root of 46. So where would that lie? It should be between 6 and 7, right? Should be between 6 and 7. Square root of 46. I'd approximate just under 7, so probably like 6.8 if I was to approximate. And then the decimal, oh, it is 6.8. Okay, the decimal is 6.8, so that worked out. Okay, so this one we're going to approximate. So now, square root of 18, that's just a little bit bigger than 16, so 4, 2 times 4-ish, I'm going to say that's about a 9, if I'm approximating. 2 times about 4 something. Okay, square root of 37 is almost 36, so 6. 5 times 6 is about 30, so I'm going to say 30. I'm going to say approximately 39 is my approximation. Okay, when you put in your calculator, it kicks out 38.9, which is extremely close again. Just a math wizard, yep. Just need to get a hat. Okay. Square root of -5, so that's just a little bit bigger than 2, so we'd probably approximate. Now this negative is not inside, so it's okay. Remember, we can't do this. We're not allowed, but if it's outside, that's okay. So my approximate would be, we can say -2.25. Okay, and then the actual is going to give us -2.2. Okay, and that next one is just a square root, then square root again. Just take it piece by piece. Okay, just taking it piece by piece. So I'm going to square root 95, which is almost 100. Okay, so I'm going to make it about, maybe a 9. So then I'm going to go square root 9. It's almost a 3, so my estimate would probably be a little bit bigger than 3 because I know it's going to be bigger than 9. My estimate would probably be 3.3 for my estimate. When you put that in your calculator, how you want to put that, you would just do square root 95, and then have a square root over that. Just make sure you use brackets, or you can do it piece by piece. Just as long as you have the bracket, yeah. Should be able to. Let me try it. Yeah, it does. Well, aren't you guys lazy? Yeah, it's fine. Okay, good. 3.1. All right. Okay, example 3, estimate to one significant digit. So we're going to estimate 6210. What could that be? 6210. Yeah. Okay, well, if we're estimating, they kind of break it into sections, but if you're estimating to one significant digit, it's just going to be, they get 80. So that was just them thinking like this is almost 6,400. So 80 times 80 is 6,400. So that's just kind of them doing that. They kind of broke it down, just looking at 62, and then times it by 10. Okay, so for this one, estimate to one significant digit. So they broke it up to looking like this and like that. So 821. So what's the square root of 8? Like, well, close if you're estimating. 3, so then they put 300. Like 300 would be somewhat close. Yeah, this estimating is kind of, I don't think this is that really important. Yeah, you can definitely just punch it in, for sure. But it's just, they're just trying to get you to get a number sense of, like, 300 would be a good estimate for that. Okay, for this one, we break it up to 24 and 3. What's square root of 24 almost? Right, so 0.05. The reason it's 0.05 is because it's going to be, when you're doing decimals, they get kind of weird. They kind of do the opposite. Instead of getting smaller, they get bigger. So 0.05, or excuse me, instead of getting bigger, they get smaller. So 0.05, if you square it, it's going to get to be 0.0025. So if you squared this, it goes 0.0025, which is really close to that. Okay, and the same thing here. Except we're going to break it off here because this is the hundredths. So this is 200ths. So what is something close to that? What's like square root of 2? 1. Okay. So we're just going to go 0.1. All right. Enough with the estimating because Mike's done with that. Okay, so cube roots. Remember, the thing with cube roots is different than square roots is cube roots are odd. You can have negatives. Okay, they can be negative. So square roots are positives only. So square roots are nice because they just stay very isolated to positives. Okay, with cubes we can have negatives. So that's what we're talking about right here. So cube root of 1,000 is 10. Cube root of negative 27 is negative 3. Okay, that is possible. Okay, the reason being, let's just go and walk through that. This is just 10 times 10 equals 1,000. 10 times 10 times 10. This would be times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9 times a negative 3 is a negative 27. That's where that comes from. Okay. All right. So then we have, oh no. What page are we on? 25? Did it again. I know. Failing. Let's just do this. It's probably faster. Okay. It's coming. Stop. All right. Okay, so in each of the following, estimate the value mentally. Use the whole number. So cube root of 11, again, we're just going back to the top there, is something going to be a little bit bigger than 2. Yeah, Jose? Yep. So cube root of see here. I would say 2.2 would be my estimate. Okay, and that's what it is. Okay, cube root of 120 be something just bigger than 5. We can just say 5.1. Be a good estimate. It's 5 or 4.9. Oh, because it's smaller. Yeah, that's a bad estimate. It's all right. So the actual is 4.9. This one was the actual and our estimate. Okay, and C, so square root of 70, so it's a square root. That's close to 64, so it's a little bigger than 8. So I'd say this is about 32 minus cube root of 70 would be just under 5. I'll probably do 16. I don't know. I'll probably say 16 for my estimate. And when you put in your calculator, you're going to get 17. It's good. All right, last couple here. My voice is even tired. Okay, so extension. All right, so the absolute value of a real number can be defined as the principal square root of the square root of the number. So 6 equals 6 squared, which is 36. Square root of 36 is 6. Just showing you the kind of the backwards way of doing it. So if you think about where square roots come from, it's always the number squared. So like square root of 36 is being 6, because you can also write 36 as just 6 squared. Well, the thing is, you can also write that with a negative 6 squared. That also gets you 36. Okay, for a real number A, the absolute value is written absolute value A, so that's kind of, we want it to stay positive. So we're going to say absolute value of 6 is 6, absolute value of negative 6 is 6. So the principal root is just saying they want you to have the distance from 0 for that. So negative 6 and 6 are the square roots of 36. But we want the distance from 0, so remember, whenever we talk about distance, can you have a negative distance? No, we can't have a negative distance. That's how they get 6 and 6. They just leave it 6. So the principal roots, okay, is just 6. That's why I know it looked weird earlier. It says you can have a 6 or a negative 6, but then it says, but don't write negative 6. All right, so all right, let's finish this up here. All right, so same thing for that. That's just the 4, and we got these last two. All right, so this is evaluate negative root, absolute value of negative 7 plus 7 absolute value. Remember, that's just going to be 7 plus 7 equals 14. Remember, absolute value is distance from 0. That's kind of what we're talking about in terms of the principal root. Next answer would be 4, yes. Absolute value of negative 4 is a positive 4, distance from 0. Okay, 81 square root is 9, so it's a negative 9. So absolute value of negative 9 is 9. But this negative on the outside, we can't stop. So that stays negative, so your answer is a negative 9. That's the only way you get negative if the negative's outside the absolute value. Okay, in each case, state the absolute value inequality represented by the graph. So this right here, absolute value of A is less than or equal to 3. So that means that anything less than or equal to 3 will work, absolute value. That's what the dark means. Negative 2, negative 1, all these things less than 3. What's this one? Absolute value greater than, is it equal to or not? No, because why? Open dot means it's not equal to. Okay, very nice. All right, and that was it. I know you're wore out, so if you have more questions on that one, you can definitely ask me. Okay, so we try to do 2 lessons in one there. All right, let's close this thing down.